In order to connect to your server over SSH, you'll have to use a terminal emulation program. That's a program that's designed to act like you're sitting at a terminal typing commands. For Windows, I recommend using PuTTY. It comes with another utility called PuTTYgen, which we'll use in a later lesson. Please download both, or just download the entire software suite. Browse to putty.org. Please don't download this from any other site. You could be getting PuTTY that's packaged with malware. So putty.org. Under download PuTTY, it says you can download PuTTY here. Click on here. Download the 64-bit MSI installer. Go to the folder where it was downloaded. Double-click on the installer. Click Next. Keep the default path. I like to have a shortcut on the desktop. That's your preference. Click Yes to save changes, to make changes, then Finish. The README pops up. You could just close that. Close the folder. And you can see several tools were added, including Pageant, PSFTP, and PuTTYgen is also there. And PuTTYgen we'll use in a later lesson. For now, we'll just open PuTTY. We'll need the IP address of our server. Remember, the command to look that up is just IP ADDR, and pipe that out to grep and look for INET. So it's 192.168.254.105. If you're going to be using this often, you might as well just save the profile. And I just name it whatever the server name is. And this way we can just double click on that in the future and just connect. Okay, so just like before, we get the server's host key the first time we connect. What this does is it's like a fingerprint of the server. So if we try to connect to this same server again in the future, it's going to see if this fingerprint matches. If it does, it won't give any problem. If it doesn't, it could mean that there's somebody trying to get in between you and your server. It's called a man-in-the-middle attack. And we're connected. In future lessons, we're going to learn how to configure PuTTY to use Pageant to save our key, and we'll connect with public key cryptography. But that's it for now, how to connect with Windows using PuTTY. Password authentication is okay, provided you create a strong, difficult to guess or crack password. We're going to look at key-based authentication and why that's even better. Here are a few examples of some passwords. These passwords, password and password with some special characters in it, are very bad, both because they're too short and based on dictionary words, and because many people use them. So the bad guys know they're used, So the bad guys use them and try to log in with them. Here are some better passwords. Sector is a security conference in Toronto. So you can substitute E's for 3's. It's like a backwards E kind of. O's for zeros. 1's for I's. There are many substitutions you could try. But this password is pretty long. It has upper and lowercase letters, special characters like the hyphen, and numbers. Here's another passphrase. Ubuntu Server Remote Admin. Passphrases can be longer, but they can be easier to remember. They can be sentences, lines from songs, titles of books, phrases from books. Pick something that's relatively easy to type and remember. Even a good password or passphrase, though, could be compromised. Compromises happen all the time, and if your email and password were stored on a server that didn't secure them properly, and that server was breached, your password and passphrase and the login you used could be out on the internet. Here's an email address I used many years ago. You can see that it's been in 8 breaches. So I used that for an Adobe login. And if I used the same password for other sites and the same login, those would be compromised as well. It's good not to reuse passwords. You could use a password storage utility like LastPass or KeyPass. However, we can avoid passwords and their problems for SSH login at least. We'll use public key encryption. Public key encryption makes use of a public key and a private key. These will be generated for you, but the process depends on what utility you're using. We'll cover Linux and Mac first, and then go over Windows in a separate lesson. When you're using public key encryption, you'll have a private key that must be kept private and never given out. You keep it locally on the server that generated it. It's used to encrypt things that are being sent. You'll also have a public key. This may be given out when needed. It will be sent to the remote server, and it will be used to decrypt things that were sent. Here's what a public key looks like. You can see it looks like an amazingly long and complex password or passphrase. If everything is set up correctly, this should be practically impossible to crack. But it's also paired with a private key that looks very similar. It's also very long and random. These two are used together to encrypt and decrypt messages. In order to use public key authentication, you'll have to generate your keys. Linux provides a tool that makes this process easy called SSH keygen. It's also used in Mac OS X and BSD. Typing SSH keygen will generate your public and private keys and save them in the default location. My keys will be stored in Home, username, which is Theo, in a hidden directory .ssh. And the files will start with ID_RSA. We'll accept the default by hitting enter. And please always put a passphrase on your keys. That way, if anyone is ever able to get your key somehow, they won't be able to use it without the password. So use this pretty strong password or passphrase. You'll be asked to put it in again. Put the same password in again and hit enter. And it saves the private key to home.theo.ssh ID_RSA, and the public key is the same location with ID_RSA.pub. You don't have to worry about this fingerprint or the key's random art. This is just trying to show you that the key is kind of random and would be hard to crack. So if we do a ls alh on our home directory now, there's a .ssh folder. You can see the permissions are read, write, and execute for the user, but nothing for everyone else. So people can't even read what's in this folder. And the utility automatically set that up for us. And then looking at the files in the folder, we have ID_RSA and ID_RSA.pub. ID_RSA is also restricted. It has only read and write for the user and nothing for anyone else. ID_RSA.pub is supposed to be readable by others. If we look at the public key, that's what it looks like. There's a command called ssh copy ID, which will copy our key to the new server. It will use locally available keys to authorize logins on a remote server. So we'll type ssh copy ID, Theo, that's the username I used, at the remote server IP. We've never connected to this server before, so we get this message to just type yes. Put in your password. And your key was added. So it's telling us we can log in and make sure our key was added. So we'll do that. Put in the password for your key. And we're in. What happened when we did that was that our key was put into a file called authorized_keys. So you can see that's the key that we had before, the public key. So it automatically made this file authorized keys for us, and it made the correct permissions. If any of these permissions aren't set right, your login won't work properly. So using these automated tools did that for us. You may wonder, why all this extra security? Why would anyone attack my server? I don't have anything valuable on it. Unfortunately, attackers likely don't care who you are or what's on your server. There are people and programs constantly scanning the internet for vulnerabilities. They'll automatically, or through manual intervention, leverage those to compromise systems. I spun up a disposable server on DigitalOcean to illustrate this. This server was set up about 5 days ago. If we take a look at var log auth.log, which is where authentication attempts are logged, we'll see that there are a whole lot of people trying to log into this server. There's no reason anyone should log into this server. This is my server. I didn't authorize anyone to connect to this. This will happen to any device you have on the internet listening on port 22. You can see there are attempts to log in as root, foobar, many usernames. Let's see how many connections were attempted using invalid usernames. We can see that the word invalid is used in lines that have an invalid user. Oh, we have to use sudo. We'll grep for invalid in var log auth log, and we'll send the output to word count -L, which will tell us how many lines. So there are 1,089 attempts. Let's see how many people tried to log in as root. (2,477). So people are constantly attacking your servers, trying to find vulnerabilities. In a future lesson, you'll learn how to disable password authentication, so all of their attempts would automatically fail even if they knew your password. Until you do that, Ubuntu will automatically fall back to password if key-based authentication doesn't work. And we don't want that. So that's it for key-based authentication with Linux, and the procedure is the same for Mac OS X. See you in the next lesson. In the last lesson, you learned how to set up key-based authentication for Linux and Mac OS X. In this lesson, we'll learn how to configure it for Windows. We'll also learn to set up key-based authentication manually without the aid of SSH copy ID. We'll start by adding a new user to our server and giving it sudo privileges. Remember, the command is just sudo add user and then the username. Enter your password. Enter your password for the new user. We'll enter through all this. And our user's configured. Now we have to add the user to the sudo group so it'll have sudo permissions. To add the new user, it's just sudo usermod -a capital G group name and then username. Then we could grep for that user in the group file and make sure it's correct. And we can see it's added to the sudo group. I'm going to print our IP address so we can use it later. So it's 192.168.254.105. The things we have to accomplish are the same as what we did with Linux, but the tools we use will be a little different for Windows. In a previous lesson, we downloaded a component to PuTTY called PuTTYGen. We're going to use that now. So type puttygen. And this is how we generate our keys. It'll generate our public-private key pair when we click on Generate. So you click Generate, it'll ask you to move your mouse around to generate some randomness used by the key, used to create the key. And here's our public key, which we'll paste into our server. Now we'll go into Putty, and our server is 254.105. Which is the same as we have here. So we'll click Open. We have to log in using our password because we haven't saved our public key to the server yet. We're going to make a directory called .ssh. And we're going to set the permissions on that to 700. We can see it's read, write, and execute for the owner, but nothing for all others, so no one else can see what's in there. Then we're going to touch a file called authorized_keys. And we're going to change the permissions on that to 600. And we see our permissions are right. It's read, write for the owner, no permissions for everyone else. You may be tempted to create your authorized keys file using Vim or Nano and pasting your key into it. I recommend using this method that I'm going to show you instead. Copy the public key you had in puttygen. Type echo, double quote, and then paste. All you have to do is right click to paste. And redirect that output to your authorized keys file. You're already in the .ssh directory. Now we'll just pipe that out to authorized keys. Excuse me, redirect, not pipe. And we'll cat the file to make sure it's there. The reason I recommend this method instead of using a text editor is that a single typo, even one that you can't see in this file, will make it not work. So you could be pulling your hair out wondering why it's not working. Could be some invisible thing like a hard return or something in your file that you can't see. This method works well for me. You can try others if you'd like. We'll keep this session open and we'll test by opening another window. Now we have to go back into puttygen and save our public and private keys. So click on Save Public Key. You can put them in Documents. I would make another folder. I'll name mine ssh_key.pub for the public key. And then we'll set a passphrase for our private key. And we'll save it. And leave the default extension of .ppk. Now back in PuTTY, we'll go back into our saved session. Click on the plus next to SSH if you have to. Then click on Auth. Now we're going to browse to our key. And we're going to click Open. Then we'll go back up to Session. And we'll save this. Now we'll open it by double-clicking. It's asking us for the passphrase for the key, so we'll enter that. And we're in. We just authenticated using our public key. We'll make sure our sudo permissions work. And we're good. Because of all the steps involved, you may run into some trouble when you try this the first time. We're going to talk about some troubleshooting steps now. A log file you want to look at for remote login troubleshooting is the auth log. You can see it says accepted public key for Theo Win. That means it worked successfully. If something's wrong, you'll see something like access denied or permission denied or some message in here that will help you in troubleshooting. The first thing we'll check though is to make sure that the SSH service is running. To do that, you type service SSH status. We can see that it's running and it's loaded. If it weren't running, we would type sudo service SSH start. The next thing to check is networking. We'll do sudo netstat tanup grep SSH. We don't really need UDP in this, but I'm just in the habit of typing that. And we can see that it's listening on all IP version 4 addresses, so that's good. If it weren't listening, we'd want to troubleshoot why. We'd want to check out whether the service is starting correctly. The next thing to check is the UFW firewall. So we type sudo UFW status. We can see that port 22 is allowed from anywhere, so that's good. If it's not one of those things, we start looking at permissions on the file and the authorized keys file. So we'll look again at our home directory. We see that the permissions are set at 700, so that's good. And we see the permissions for the authorized key file are also set correctly at 600. And the content of the file looks good. If all those things looked correct, the next thing I would try to do is clear and re-enter the text into the file. There could be a typo in there that we just can't see. To clear the file, you can just type echo and open and close double quotes with nothing in between, and you send that into authorized keys. We can see that the file is empty. It has just one space in it right now. One hard return in it right now. And we'll paste our key back in again. I would not use the up arrow for this. I would do it fresh, but I know my key worked, so I'm just going to hit the up arrow. We'll cat the file again. Now it has an extra space in it. It should still work though. We're going to test that. And it worked. So it's okay to have something in your authorized keys file as long as it's not in the key itself. If you have a space or carriage return and it's not interrupting your key, it's okay. If you've tried all of the above and you're still having trouble, please post a question in the Q&A section of the course, and one of your fellow students or I will try to help you. You can also Google for help, and there's more information in the downloadable article for this lesson. Good job. See you in the next lesson.